So, you've probably heard a ton about generative AI, right? But have you ever wondered what's really going on inside that so-called black box? Well, today, we're going to pop the hood and take a tour of the core concepts that make this whole thing tick. We're skipping the heavy jargon and getting right to the essential building blocks. Ready to see how it all fits together? Let's dive in.
All right, here's the map for our tour today. First up, we'll swing by the supply room to check out the raw materials, the building blocks of language itself. Then it's off to the translation department, where we'll see how an AI actually figures out what things mean. After that, we get a special look at the central command center, where the AI brains are running the show. And finally, we'll watch the assembly line to see how these amazing models are built and sent out into the world.
Okay, first stop. And this is quite literally the foundation of everything we're going to talk about. Before an AI can write a single line of code or a beautiful poem, it has to learn the absolute basics of language. So where does it even begin? Let's take a look.
It all starts with something called a token. And honestly, the best way to think about tokens is they're kind of like the Lego bricks of language for an AI. They are the smallest, most fundamental pieces the model works with. Sometimes a token is a whole word, like cat, but other times it might just be part of a word, like ing. And this is super important, because by breaking language down into these predictable little pieces, the AI can process it way, way more efficiently.
Now, a model can't just look at an infinite number of these tokens all at once. That would be chaos, right? That's where something called the context window comes in. You can basically think of it as the AI's short-term memory. It sets a hard limit on the number of tokens, the amount of information it can hold in its head at one time to understand what you're asking and figure out what to say back.
So if the context window is like short-term memory, you're probably wondering what happens when you have a document that's way too long to fit. That's where a clever little trick called chunking saves the day. We just break that huge document into smaller, bite-sized pieces or chunks that fit perfectly inside the context window. It's how the AI can tackle even the longest books or reports, one manageable piece at a time.
All right, let's head to the next stop on our tour, because this is where things get really interesting. See, knowing the words is one thing, but understanding what they actually mean and how they relate to each other, that's a whole different ballgame. This is where the real magic starts to happen.
Let me ask you something. Have you ever been scrolling on a shopping site and it just seems to know you? It suggests a product that's so perfect, it's almost spooky. Well, I promise you, it's not magic. It's actually a core AI concept in action.
The secret ingredient is something called embeddings. Think of an embedding as a universal translator. An AI doesn't understand the concept of king or queen the way we do. Instead, it converts those words into a special numerical code, an embedding. And that code doesn't just represent the word, it represents its meaning and its relationship to every other word out there.
This is exactly how it works. That shopping app turns your profile, what you've clicked on, what you've bought, it turns it all into these numerical codes. And then it's just a game of matching. It looks for products with similar codes, and boom! That's how you get those shockingly good recommendations. It's not magic, it's just really, really clever math.
Now, these numerical codes we keep mentioning, they have a technical name, vectors. And just like latitude and longitude can pinpoint a location on a map, a vector pinpoints a word's location on a giant, multidimensional map of meaning. And on this map, words with similar meanings like dog and puppy or king and queen are found right next to each other.
Okay, so we've seen the raw materials and we've seen the translation process. Now it's time to go to the main floor and meet the real brains of the operation, the AI models themselves, the things that actually do all the thinking.
The engine driving most of the AI we use today is something called the transformer architecture. These are the famous large language models, or LLMs for short. You can think of them as a kind of artificial brain. They take all those tokens and vectors we just talked about, process them, and then generate brand new human-like text. This is the core engine that makes tools like ChatGPT so incredibly powerful.
And just like with car engines, there are different types for different jobs. You've got your foundation models, which are these massive general-purpose AIs that can be customized for specific tasks. Then you have multimodal models. These are the multitaskers that can understand not just text, but images and audio too. And finally, you have diffusion models, which are the artists, creating those mind-blowing realistic images you see online.
So, we've got these super powerful models. How do we actually get them to do what we want? Well, that's a skill called prompt engineering. And you can think of it as simply giving the AI really, really good instructions. If you ask a vague question, you're going to get a vague answer.
But if you craft your prompt carefully, you can unlock the AI's full potential and get some truly amazing results. All right, for our final stop on the tour, let's check out the assembly line. I mean, how do these unbelievably complex models go from just an idea, a blueprint, to a real tool that millions of us can use every day? Well, it's a pretty detailed step-by-step process. Here it is, the entire life cycle from start to finish. It all kicks off with gathering enormous amounts of good data and choosing the right model architecture. Then comes pre-training, where the model learns all the general stuff. After that, it gets fine-tuned to become an expert in a specific area. Before it ever sees the light of day, it's tested like crazy for safety and performance. And even after it's deployed, the learning never really stops.
Now, during that training stage, you might hear a term thrown around, epoch. It sounds super technical, but it's really simple. One epoch just means the model has gone through its entire training data set one single time. And of course, these models are usually trained for many, many epochs to really make sure the learning sticks.
So this is a really crucial point to grasp, the difference between pre-training and fine-tuning. Think of it like this. Pre-training is like a person getting a general university education. The model learns about language, history, science, reasoning, all from basically reading a huge chunk of the internet. Fine-tuning, on the other hand, is like getting specialized on-the-job training. That smart, well-educated model now learns to become an expert in one specific thing, like analyzing legal contracts or writing code.
And that really brings our tour to a close. You know, as this quote says, you don't need to have a PhD in computer science to understand or even use this technology. The whole point is to have a good, high-level grasp of these core ideas. And hopefully after this tour, you do. So we've seen the building blocks, we've seen how they think, and we've seen how they're built. Now that you have an idea of the foundations, the really exciting question becomes, what's next? What new doors are these models going to unlock? Honestly, it feels like we're just getting started.